Hello everyone, welcome to Brain Blitz Audio. Today in this episode of JEE Mains, we'll be looking at previous year questions of mathematics in engineering entrance exams in India. So today we're dealing with sets, relations, and functions. This is one of the important topics that are asked in JEE exams. So this topic deals with sets and the relations between sets and also the special type of relations that we call functions. So today, let's start off with this question. Which one of these functions is not periodic? Is it option A, option B, option C, or option D? This question is asked in 2002, and for that we need to know the periods of the trigonometric functions given here. So in option A we have mod of sine 3x plus sine square x. So mod of sine 3x is pi by 3. So let's write that. Let's write the periods of the given function. So mod of sine 3x is pi by 3. Mod of sine square x is equal to pi. And for cos 4x, the period is pi by 4. And then for tan square x, it is pi. Cos 2x gives you pi by 2. Sine x equals 2 pi. And cos square x is pi as well. So based on the given periods and the periods that you've already memorized, you would know that options A, C, and D are incorrect. These are periodic functions, but option B would be the correct option. Now, how do we do that? In option B, cos square x has the period pi, so it appears to be periodic. But we also need to find the period of cos root x. So for cos root x, let's consider f of x to be equal to cos root x. And we also consider that f of x plus, say, t is equal to f of x. Now that means cos of root of t plus x is equal to cos of root x. That means root of t plus x can be written down as 2n pi plus minus x, root x, because to find the angle theta for a cos function, you use the general solution formula 2n pi plus or minus theta, or which in this case is root x. Now here you notice that in root x, x can only have positive values. So therefore t is always dependent on x. T is dependent on x at all values. So f of x, that is equal to cos of root x, is not periodic. So if a periodic function is added to a non-periodic function, then the resulting function becomes non-periodic. So therefore the right answer is option B, cos root x plus cos square x. Now let's look at the next question. We need to find the period of sine square theta. So whether it's pi square, pi, pi cube, or pi by 2. Now, let's look at the period for sine theta. So sine 0 is 0, and then after 2 pi it becomes 0 again, so that is a whole period. So the period for sine theta is 2 pi. And for any sine k, we can write the period as equal to 2 pi divided by k. So how do we prove how do we find out the period of sine square theta? Now, here what we can do is we can use cos 2 theta is equal to 1 minus 2 sine square theta. So therefore, 2 sine square theta is equal to 1 minus cos 2 theta. Let's write it here as well. So what happens is that now 2 goes to the other side, to the right hand side, so the right hand side is now divided by 2. So therefore, sine square theta is equal to 1 by 2 times 1 minus cos 2 theta. So if you notice, the period of cos theta is also 2 pi, because cos 0 is 1 and cos 2 pi also becomes 1. So therefore, you can write cos 2 theta's period as 2 pi divided by 2, which is equal to pi. And if you add that terms which are not trigonometric, then the period does not change. So adding and multiplying constants does not change the period. So therefore, the period of sine square theta is also equal to pi. So therefore, among the following options, option B is the correct option. Let's look at this question. The domain of sine inverse of log to the base 3 x by 3 is. So we have 4 options, and this question was once again asked in 2002. So now let's look at this question. So now let's consider, if sine of y is equal to x, then you can always say that y is equal to sine inverse of x. Now, in this case, x can be written as log to the base 3 x by 3. So this is the variable. So that means we can use the domain of sine inverse x and then modify it with respect to log to the base 3 x by 3. So for y equals sine inverse x, the graph is like this, and the highest peak is at 1 and the lowest peak is at -1. So therefore, you can write -1 less than or equal to x less than or equal to 1. This is the domain of sine inverse of x. So for sine inverse of log to the base 3 x by 3, the domain will be -1 less than or equal to log to the base 3 x by 3 is less than or equal to 1. So on removing the logarithm, what happens is that the base is now the base is now, what happens is that the left limit becomes the base raised to the current limit, So that means 3 raised to minus 1 less than or equal to x by 3, since the limit is gone. I mean, the logarithm is gone. So less than or equal to, the right hand limit also becomes base raised to current limit. So that means 3 raised to 1, which is 3. So therefore 1 by 3 less than or equal to x by 3 less than or equal to 3. So what you now do is multiply 3 on all sides. So that means 3 by 3 gives you 1 less than or equal to x less than or equal to 3 times 3, which is 9. So the domain of sine inverse of log to the base 3 x by 3 is the closed interval 1 to 9. So that means option A, closed interval 1 to 9, is the correct answer. Now let's look at this question. The function fx equals log of x plus root of x squared plus 1 is A, an odd function, B, a periodic function, C, neither an even nor an odd function, D, an even function. So this question was asked in 2003, and in order to solve this, we will use the value of minus x for the function. So f of x can be written down as log of x plus root of x squared plus 1. And this isn't a periodic function. Periodic functions are usually trigonometric, so option B can be discarded. So it's basically whether it's an even or odd function. For an even function, f of minus x is equal to f of x, and for odd functions, f of minus x is equal to minus f of x. So let's put in the value of minus x for this function. So f of minus x can be written as log of minus x plus minus x the whole square plus 1 the whole root. Minus x plus under root of minus x the whole square plus 1. So this is the value of f of minus x. So minus of x the whole square can be written down as x squared. So this f of minus x will become log of minus x plus x squared plus 1. So this doesn't get us anywhere. So what we're going to do is we're going to multiply and divide by x plus x squared plus 1 the whole root. So that means f of minus x will now be equal to log of minus x plus x squared plus 1 the whole square times x plus x squared plus 1 the whole square divided by x plus x squared plus 1 the whole square. So inside the logarithm, the denominator is x plus root of x squared plus 1. Now the numerator is the product of minus x plus root of x squared plus 1 and x plus root of x squared plus 1. So therefore, now let's start multiplying. Minus x times x gives you minus x squared plus minus x times the root x squared plus 1 gives you minus x times x squared plus 1, and root of x squared plus 1 times x gives you plus x times root of x squared plus 1, and multiplying root of x squared plus 1 with root of x squared plus 1 is essentially making it squared. It's essentially squaring it, so you will get x squared plus 1. So this is the numerator. So in the numerator, you can see x squared and minus x squared cancel each other out. Minus of x times x squared plus 1, the whole root, plus x times x squared plus 1, the whole root. Both of these, when added together, gives you 0. So therefore, the right hand side now becomes 1 divided by x plus x squared plus 1, the whole root. Now, this is basically x plus root of x squared plus 1 raised to minus 1. So therefore, we can write the right hand side as log of x plus root of x squared plus 1 whole raised to minus 1. So now in logarithm, log x raised to a is equal to a times log x. So therefore, f of minus x can be written down as minus log of x plus root of x squared plus 1. So that means f of minus x is equal to minus f of x. So therefore, f of x is an odd function. So therefore, option A in this question is the correct option. So to find an odd function, we put in the value of minus x, and by simplifying it to get minus f of x, we prove that f of x equals log of x plus root of x squared plus 1 as an odd function. This is the final question of this episode. A function f from the set of natural numbers to integers is defined by f of n equals n minus 1 by 2 when n is odd, and f of n is minus n by 2 when n is an even. When n is an even number. So you need to find out whether the function f is 1, 1 onto but not 1, 1, 1, 1 and onto both, neither 1, 1 nor onto, 1, 1 but not onto. So this again is a question asked in joint entrance examination in 2003. So let's look at this question. So this question will have two parts, because when n is odd, the value is different, and when n is even, the value is different. So therefore, we'll need to do two cases for the 1, 1 onto proofs. So first, to prove that f is 1, 1. Now let's consider f of n1 equals f of n2. So an odd number can be written down as 2n minus 1. So let f of n1 let n1 be written as 2 into n1 minus 1, and n2 be written as 2 into n2 minus 1. So for an odd number, the function is n minus 1 by 2, so that means 2n1 minus 1 divided by 2 equals 2n2 minus 1 divided by 2. It is basically 2n1 minus 2 divided by 2 equals 2n2 minus 2 divided by 2. We can simplify that as 2 into n1 minus 1 divided by 2 is equal to 2 times n2 minus 1 divided by 2. 2 gets cancelled, so n1 minus 1 equals n2 minus 1. So that means n1 is equal to n2. when n is odd. So for n is even, let f of n1 is equal to f of n2. Then you can put in the value of the function. So for even numbers, it is minus n by 2. So therefore, minus n1 by 2 equals minus n2 divided by 2. So you can cancel out the denominator from both sides. So you'll get n1 is equal to n2. This is when n is even. So you can now write that the function f is 1, 1. Now to prove whether the function f is on 2. So now let's look at the odd case and even case separately for on 2. So let f of n is equal to n minus 1 by 2. So n minus 1 by 2 can be written as 1 by 2 times n minus 1. So take the first derivative for this function. So that is d of fn by dn. So which we can write as f dash of n is equal to 1 by 2 times 1. So therefore 1 by 2 is 1 by 2 is greater than 0. So therefore the derivative of the function n is greater than 0. So this is possible for all n belongs to natural numbers if the value of n is odd. Similarly, let's look for even. The case in even, let's take the even case of this function. So let f of n is equal to minus n by 2 for n being any even number. So taking the first derivative, you get f dash of n is equal to minus 1 by 2, which is less than 0 for all n belongs to natural numbers when the number n is even. So for the given domain, the function is an increasing function or a decreasing function. So in the first case, for the given domain, the derivative is positive. That means the function is decreasing. And for the second case, the first derivative is negative, so the function is increasing. So therefore, when a function is increasing or decreasing with respect to its domain, then the function f is on 2. So therefore, now we've proved that the function f is both 1, 1 and on 2. So therefore, option B, 1, 1 and on 2 both, is the right option. Now that concludes this episode of JEE Main. We hope you found this episode interesting. For more of our videos, don't forget to subscribe to our channel, which is Brain Blitz Audios. And to get more videos of this playlist, you can click the link in the description down below. Let us know what you feel in the comment section down below, and we'll see you next time. Until then, take care and stay safe.